for in the nuclear energy space. And so there's really 4 tenets to the NE mission. Those include the maintaining and sustaining the reactor fleet, developing and deploying new nuclear reactors, sustaining the nuclear fuel cycle, and enabling international energy cooperation. And so with those 4 tenets, it's important as you develop your applications, regardless of what the technology area you're working in or where you're looking to propose, that you address the overall NE mission in that space. And so there are a few things that are not of interest to the NE mission. Those include medical physics, nuclear fusion, nuclear forensics, and environmental management. And those are areas that belong to other government agencies or other offices, and so we don't cover items that fall into those different categories. So with that, I want to introduce Janelle Edens. I'll let her give her title and kind of an overview of what her responsibilities are at the Department of Energy. And I'll let her introduce each of the different advanced reactor program managers. And what Janelle and the program managers are going to do is introduce themselves, but also give you an idea of interesting or relevant ongoing activities related to the different advanced reactor concepts. That way you can get an idea from a program space of what the focus of the department is. Now for the CI&R funding opportunity, we're focused on NE mission relevance, which means if you'd like to try to integrate or work with the programs more closely or propose something that's very close or well integrated with the programs, that's fine. But if there's other ideas where you've identified a gap and it's not something that the program is currently pursuing, but is good science and is an identified gap that you can make a good case for, those applications are also welcome because we're looking for new concepts and new ideas in these spaces. So with that, I'll turn the time over to Janelle to take over the mic. Go ahead, Janelle.
Thanks, Drew. So good morning, everyone. Like Drew mentioned, my name is Janelle Edens, and I am the Advanced Reactor Development Team Lead within the Office of Nuclear Energy. And I'm also serving as the Interim Program Manager for a Molten Salt Reactor Research Program. So like Drew mentioned, topic area 1 is focused on reactor development and plant optimization. So with this topic area, we're looking for innovative ideas that could help reduce the technical risk for advanced reactors, as well as activities that could help optimize the design and future operation of advanced reactor concepts. So in the topic area, we list a number of potential activities that could fall within this topic area, but I will note that this list is not meant to be all-inclusive. So we're certainly open to any other novel ideas you may have. I also want to add that this topic area is focused on advanced reactors, so pretty much any reactor that's not part of the existing fleet. So that would include any of the non-light water reactor concepts, as well as the light water small modular reactor concepts. And like Drew mentioned, there are a number of ongoing programs within NE that support work that's relevant to this topic area. I would say that the primary program is the Advanced Reactor Technologies, or the ART program. And in that program, we're working with a number of key stakeholders, such as universities, national labs, and industry, to help reduce the technical risk for these non-light water reactor concepts. And within the ART program, we support research campaigns on molten salt reactors, high temperature gas-cooled reactors, microreactors, and fast reactors. So I'm going to briefly touch on the MSR program, and then the other ART program managers will briefly summarize their programs. And with the MSR research campaign, we support reactors that use molten salt as the coolant. And that program supports 2 variants of the MSR. One variant uses solid trisofuel, and the other variant has the fuel dissolved in the molten salt coolant. And in that program, we're primarily focused on investigating fundamental salt properties as well as developing materials, models, and other technologies for MSR concepts. So a lot of the research that we're doing in this program is fundamental in nature. So that lends itself pretty well to being done at a university. Then before I turn it over to the program managers, I did want to briefly touch on the National Reactor Innovation Center, or NRIC. And within that program, we support a number of activities to help accelerate the demonstration of advanced reactors. So one key thing we're working on there is the establishment of 2 test beds at INL. And these test beds will be capable of hosting experimental reactors that industry can use to generate data to support their design and licensing. And another area that would be of interest to this group is the Advanced Construction Technologies Initiative, or ACT. And with this initiative, NRIC is working with a team that's being led by GE Hitachi to develop advanced construction technologies that could significantly reduce the cost and schedule for new nuclear builds. So I will drop the website for NRIC as well as the ACT initiative in the link. But for now, I'm going to move on to the ART program managers, and we'll start with Kat.
Good morning. My name is Kat Abbott. I'm the program manager for the Fast Reactor program within ART. Just kind of from our perspective, our high priority areas right now are designing and developing scalable advanced technologies and options that support fast reactors, reactor designs, and reestablishing the infrastructure to support the testing of advanced technologies for fast reactor applications. One area where the fast reactor program is particularly skilled is we have the Mechanisms Engineering Test Loop Facility at Argonne. This can be used to test sodium compatibility of materials and performance of components within hot sodium in one of currently 6 test vessels that are in place at Metal. Previous elements that people have tested have included stuff like ball bearings, stuff like EM pumps. Really, what we're looking for is we're looking to be able to have a better understanding and to reduce the risk of failure in components that will go into these advanced fast reactor designs. Thank you.
Thanks, Kat. Let's move to Diana, please.
Hi, good morning. My name is Diana Lee. I am the Microreactor Program Manager, and we are focused on several different areas, fuel needs, applications through economic analyses. We're looking into different advanced materials, for example, yttrium hydride, and we have looked at grade 91 in the past to help reduce the volume of the moderator and the structural material in the microreactor. We are also have several non-nuclear test beds such as Sphere and Magnet. Sphere looks at heat pipes and understands performance in different temperature ranges and transients, and we can measure properties such as gap conductance. Our Magnet facility has been looking into how for example, a core would couple to heat pipes and heat exchangers, and then power conversion, and then end user capabilities such as high temperature steam electrolysis, and how that would all perform. We also are developing a microreactor at Idaho National Laboratory called Marvel. And when that is available, and we're targeting beginning of fiscal year 2025 to be up and running, that will be able to couple to a microgrid, and so we can then show end user capabilities such as high power computing, water desalination, electric vehicles, and other capabilities, and also process heat. So we are looking at anything that would streamline the timeline to demonstrating a microreactor and also closing regulatory gaps. Thank you.
Thanks, Diana. Matt?
Hello, my name is Matt Hahn. I'm responsible for the gas-cooled reactor portion of the ART program. We perform activities intended to address technical and regulatory gaps to enable deployment of high-temperature gas reactors, including both pebble bed and prismatic configurations. Our current activities are divided into 4 areas. Those are high-temperature alloys, graphite, modeling methods and simulation, and TRISO fuel qualification. The latter, the fuel, falls under topic area 5, fuels for the CNIR call. The high temperature alloys and graphite work perform activities that aim to understand materials behavior in the harsh conditions of HTGR reactors, including both high temperatures, radiation damage, and mechanical stresses. Our modeling methods and simulation activities include work to perform prototypical design and licensing calculations, as well as conducting experiments that yield data sets that cover the anticipated operating envelope and are of sufficient quality to validate computational models used for the design and licensing of HTGRs. Generally those with outlet temperatures in the 650 to 850 degrees C range. That's about all I have. Thank you.
Thanks, Matt. Savannah?
Hi, my name is Savannah Fitzwater. I'm the incoming federal program manager for Enric. Janelle has been kind enough to have an overlap with me. She gave you a great overview of the Enric's current activities. So I just wanted to note, in case you haven't seen it, I did drop the link for Enric and specifically the ACT initiative in the chat. So please feel free to check out those links. Thanks, Janelle.
Thanks, Savannah. And in addition to our art program managers, we also have some of our national lab experts on the line. So I'll turn to Bo Fang from Argonne to introduce himself.
Yes, so Kat gave a great overview of the Fast Reactor program. I'm the National Technical Director. Camera's not working well, sorry. I'm the National Technical Director for the Fast Reactor program. Yeah, if you have any questions about some of the work that's being done in the program, please contact me or Kat. Again, it focuses on the METL facility. That's 1/3 of our program. Another third is on databases and software for Fast Reactor licensing and for vendor use and design. And lastly, there's a materials aspect that we are investing in to develop structural materials that reduce costs and offer better performance. Thank you.
Thanks, Bo. So you've heard a lot about the non-light water reactor concepts. Now I want to turn to Melissa Bates, who leads our light water SMR program.
Thank you, Janelle. Hi, I'm Melissa Bates. I'm the Federal Program Manager for the Advanced Small Modular Reactor Research Development and Demonstration Program. That program is largely focused on the development, licensing, and deployment of a light water small modular reactor technology. Currently, we're focused on the carbon-free power project, which is deploying a 6-module NuScale small modular reactor plant in Idaho. However, we have some other projects ongoing as well. For this call, the main areas of focus are really anything that would improve small modular reactor economics or operations across, any of the technologies that industry is currently looking for. I think something that we would really look for in a application is, partnership with a reactor technology developer, showing that case that, the proposed improvement or proposed research would be supporting, the active development that's ongoing. So that's all I have. Open for any questions. Thank you.
Thanks, Melissa. And Drew, I believe we've introduced everyone on our side. I'll turn it back to you.
Okay, thank you, Janelle, and thanks for those overviews from all the program managers. I do want to mention a side note that you'll all be getting by email later today, but as Diana was talking about Marvel and its deployment, There is a Marvel preliminary questionnaire that will be put out on nup.gov. It's currently available at gain.inl.gov. If you have interest in specifically in that microreactor space, there's also an opportunity to give your perspective on what kind of research ideas you have surrounding that Marvel microreactor. So with that, we'll open this up for questions. From a format standpoint, you can put your questions in the chat, or you can raise your hand and unmute yourself and ask questions. The idea here is we've scheduled the session for 90 minutes, and we'll go for as long as there's questions. And once the questions subside, we'll have a last call, and we'll conclude the session. So with that, feel free to raise your hand, put your comments into the chat, and we will relay those to the program managers here. All right, Troy, you have your hand up. Go ahead.
Thanks, Drew. Can you guys hear me okay?
Yes.
Okay, because last time I asked, my microphone wasn't working very. But I guess this is for Janelle. You mentioned that fundamental understanding of salt properties and materials performance, within the salt is of interest to the MSR program. What opportunities would exist in this space, essentially, because for at least for universities, since there's a current IRP in that area, as well as a lot of work being done at other national labs.
Sure. So you're correct. There's a lot of ongoing work in this area, but I would say the MSR concept is probably the least technically mature of all of the concepts that we're working on. So there's still a lot of work to be done. For example, we've been collecting fundamental salt properties, thermophysical properties of salts for many years now, and we still have gaps in those areas. So we would be interested in any innovative methods of measuring those properties or measuring those properties themselves. As you know, the environment in a molten salt reactor is pretty harsh. So other things that we've been looking at is salt material compatibility, as well as compatibility with graphite. So just in summary, there is a lot of ongoing work in that area, but there's still a lot of work to be done to reduce the technical risk for these reactors. So I encourage you to familiarize yourself with the work that's being done so that you don't propose anything duplicative, and hopefully that will help spark some innovative ideas as well.
All right, well, we'll continue entertaining questions or follow-ups, Troy, if you have any.
Sure, I've got a follow-up with that. I guess this is on, again, more of the properties then. Is the interest, I guess, more like modeling the salts or experimental measurements and uncertainty quantification, or is there also interest in seeing how those salts properties would impact reactor performance?
I would say all of the above would be of interest to us. There's, like I mentioned, there's a lot of work remaining to be done on molten salt reactors. So any of those activities would potentially help reduce those risks for MSRs. So we would be interested in any of the activities that you mentioned.
Thanks.
All right, we'll continue entertaining questions. If you don't want to raise your hand and chat, you feel free to use the chat function to ask your question, and we will relay that to program managers. All right, I'm not seeing any additional questions. I will mention a few things about the CINR call, and then we'll take a last call for questions. So if you do have any additional questions, please put them in the chat at this time or raise your hand, and I'll call on you after I give a couple of updates about the CINR funding opportunity. Applications for this topic area are due July 26th, so only a few weeks out at this point. If you do have additional questions after this session ends, either for program managers or process questions for the NEUP office, please email those to neup@inl.gov, and we will, I'll put that in the chat here, and we will coordinate answers between various program managers or technical experts to get a response back to you, or answer you directly if it's a process question. All right, and I see the comment from Pear that that the programs are covered well, so that's great. And a final question here, it looks like from Amanda is improvement on corrosion resistance of structural materials of interest in this topic area?
Yes, that would be of interest in this topic area. Again, we do have ongoing work on this topic, so I encourage you to familiarize yourself with what we're doing in that space. So you don't propose anything duplicative, but anything that would be new, innovative, or complementary would be of interest.
And Amanda, there is a materials area that will be discussed on Monday, the 17th, where that could also possibly be a fit. So that may be of interest as well. All right. I think that is all the questions we have. I'd like to thank Janelle and the art team for being here and for taking your time to answer our questions. Like I said, if you have any further questions or need clarifications about the funding opportunity before the 26th, please do reach out to neup@inl.gov, and we will entertain those questions as they come. Thank you for all attending. Hope you have a good day.
Thank you.